I guess good afternoon, everyone. I think it's afternoon for everyone. I'm Jeff O'Driscoll with Associated Engineering, and I'm going to talk to you about climate risk assessment. And I'm going to focus on buildings because I think this crowd is a little bit more building centric. Associated Engineering, we're a consulting engineering company, and we have a variety of services, and we do a variety of things across the country. That's enough about that because this is more about climate resilience. So when I was approached to help out with some talks, I put a little syllabus together of what I'm going to talk about, and I really put down, I think, the how, what, why of climate risk assessment as it relates to buildings and building management and at different phases. So that's really what I'm going to talk to you about is resilience. This, in terms of sustainable building, it's adaptation. It's the result of, the greater success we have in mitigating and reducing our carbon footprint and activities in the future, the less we'll have to adapt, the less climate risks hopefully we'll have to incur. So really today is about just showing you some process about how to do a risk assessment and where, how, and a variety of things. So, the first question of when should you do an assessment? Well, I think you should be doing them all the time in terms of a variety of aspects. In recent times, I would say the federal government has tied a lot of federal funding for infrastructure for communities through a number of programs to complete a climate lens. And the climate lens has a resilience assessment and a greenhouse gas mitigation assessment. So a resilience assessment is a very good piece and sometimes necessary for those processes. So if you want your money, the federal government is saying, we want you to consider the future climate so we can invest. Municipalities across the board are really starting to look at incorporating resilience assessments in their asset management. You can, I would say you should start your assessments of climate risks at the capital master planning side. As you move through operation and maintenance, through a variety of things, you can look at your risks at those times. Portfolio applications, concept preliminary engineering design, a little bit more my world, where you get into, first of all, considering those risks and then addressing those risks in the detailed design. Green natural infrastructure assessments and a variety of ISO related products, for enterprise risk and a few things. And really, when should you do it? You should be doing it at probably all those phases of the construction, revisiting your risk assessments as climate data changes, as your infrastructure changes as well. So when should you do it? You should be doing it. So, and really we want it to become part of the business as usual practices in terms of your processes of designs, policies for municipalities, design guidance through specifications. And why complete risk assessment? Why? Because the climate's changing, because we see a lot of climate change. So, if we understand sort of the effects of global climate change, it allows us to reduce those risks. Just very fundamental. I'm going to talk a little bit about climate, but hopefully the persons involved in this audience have some basic knowledge of climate. So what, climate scientists and a variety of people have been studying the climate for quite a time, the recorded information as well as studies going back. So when we look into the 1850s up to current 2010s and current practices, we see, these are just little snapshots of the globe in terms of color, blue being colder, red being warmer, and we see this overall trend of warming. So when we look at, the progression of time through the change of the century to now, we see that we are warming, and that's just the trends. That's what the information is telling us. And really the correlation of that is, really as we've industrialized, as we've created more carbon and emitted more carbon into the concentrations into our atmosphere, we've seen a correlation and that warming. So really I wish we could put a hard stop on that, but that's just not there. So when we look at the actual boots on the ground of climate, as we move into the 2000s, the climate has been warming. And really, what does the future hold? So for us to understand the future, we have to start to model the future with global climate models and then move that forward. That takes a lot of computing power. There's a lot of assumptions in those models. So there's a lot of uncertainty, which increases the risk. But because there's risk doesn't mean we don't take action. So in many cases, we have to look at a number of climate scenarios, a number of what we call climate representative concentration pathways. And it depends on how good I would say we will be into the future in terms of our emissions, whether we can reduce them in terms of future activities, or we're not very successful, which unfortunately we're more tracking right now in terms of we see more emissions and therefore more rate of change. So something like an RCP 8.5 is a consideration of less mitigation and more change. But if we start to do a better job, if a number of these policies and actions that municipalities can do and retrofits in terms of buildings and a variety of things, maybe we can start to reduce that and we can slow the rate of change. So hopefully we're there. But currently, if there was no climate change, we would just be trucking along in this black line. But really, as we successfully move to these other scenarios, what we need to do is mitigate. We need to, the more climate change we see, the more rate of change, the more we're going to have to address that through some adaptive action. So really the inspiration is please everyone reduce and move that forward. So the impacts of not doing anything, lots of community flooding, we see that, and we've seen that in Manitoba. Hopefully we don't see too much of that this spring with all the snow we've had in terms of melting. But we see that the future, some of these high intensity rainfall events that 1 in 50 years, as we move into 2100s, those might be the 1 in 5 year events. So we're seeing the intensity increasing like crazy. We see a lot of flooding in terms of our infrastructure, our buildings, and across places. These are a couple snapshots from Toronto. We see the need for more power as we have warmer summers in terms of maximum temperatures. So our buildings need to be cooled more, and a variety of things. So there's an unfortunate side of moving to a different climate. We have, wildfire risks, smoke related to wildfire in terms of our communities. Winds, high wind events. We had that event a few years ago that devastated the Winnipeg treaty canopy. So those are important things, as well as just overall air quality that affects buildings. How we manage our buildings, how the ventilation systems work in those buildings, and the amount of outdoor public spaces that can be utilized in buildings. So climate change is real, and that's the why we need to assess those climate risks. So how do we do it? We use some standard risk assessment processes, and really that's what it is. So we'll talk about risk assessment. What a lot of my background, a lot of work is a process called the PIVC process, and some of you may have had some awareness of this, and if not, it's a systematic risk assessment process. PIVC is a acronym for a committee through Engineers Canada that was originally developed a tool. So the Public Infrastructure Engineering Vulnerability Committee, so they named the process after that. And it's really looking at how climate and infrastructure, or these elements, how they interact, and if some event hits that say the facade of a building, what is the impact of that? So the process is very much risk associated basis, where we assess the consequence. So the severity of some kind of event and the likelihood of these future events. And based on that, we can come up with a risk profile in terms of future risks being high, medium, and low risks. And where we see those high risks and medium risks, potentially, we can start to plan differently, design differently, and operate differently in terms of our infrastructure, our buildings, and other public infrastructure or private infrastructure. So that's sort of the fundamentals of a process. And I thought I would just spend a few minutes and just sharing with you how this is applied in a couple of case studies. So the overall opportunity is to see how this fits into some kind of a process, so that it's not always some tangented off to the side process. So one aspect or one project that I was involved with was a study in urban community planning for Capilano University. The university itself was looking at trying to answer a couple of questions. So really the objective of that study was, what are the university's climate change risks and how might we address them? Really fundamental question. I hope you could answer. If you're a building owner or building operator, you should be asking that question as well. And then once we know those risks, what do we do with those risks? How do we, what do we do about them? And what happens if we don't do anything about them? What is the risk of inaction? So that was the basis of this Capilano study. Capilano is a university in North Vancouver, a smaller campus, heavily urbanized, a bunch of buildings and a variety of things. So in terms of the risk assessment process, back to the PIBC process, it really has a number of very basic steps, from really defining the infrastructure that you're looking at, which is, in this case, the campus with buildings and pathways and roads and stormwater infrastructure and a variety of things. Establishing climate parameters, meaning what kind of present climate effects in terms of climate hazards, different thresholds in terms of temperatures for buildings, for building HVAC systems, for a variety of things. And then projecting those into the future, into future timeframes. Then we assess those interactions of those climate risks in terms of the infrastructure and come up with sort of a risk profile, assess that risk, and then decide what to do in terms of actions to reduce that into the future. How do we adapt? How do we mitigate? How do we find opportunities in that mitigation that also have sustainable options in terms of mitigation? So in terms of this university campus, we very much looked at their master plan. They had a comprehensive idea of how they wanted to develop the footprint of the university, as well as a couple of remote campuses, one in Squamish and another area. So we looked at the systems, building drawings, went to sites, brought a team of specialists from mechanical, electrical, structural engineering, civil engineering, in terms of teams to assess that, and really to discuss so much of this with the operations and the people responsible for the infrastructure and buildings, because they really understand how their systems have reacted in the past, where there's been challenges, where they see potential vulnerability from climate type events, high intensity wind events, lightning, wildfire, or smoke from wildfire, all of these different elements. And knowing how the infrastructure has responded in the past, we can start to sort of characterize or understand how that might react to the future. So the local understanding of their physical infrastructure is very, very important, as well as their thoughts on how they might see some adaptation measures, some idea of how to fix that. So that's the starting part of these risk assessments, is really understanding the infrastructure, sitting down with persons responsible in terms of both the management, the operation, and in many cases, other stakeholders around that process, which could be community groups, could be Indigenous consultation, could be a variety of things. So once we define that infrastructure, we start to break the system down into a model, and this is a pictorial of Capilano University. So we looked in terms of breaking the system down and assessing into a variety of things, including some wetlands, all of the electrical infrastructure in transmission, transformers, conductors, a variety of things, standby power. We looked at the forested areas, sort of the green infrastructure that's heavily prevalent in the campus and is really an asset in the campus. The road and transportation infrastructure, pathways and other parts, the slopes, some very specific areas of high slopes that could create problems, as well as all the buildings. And within the buildings, we broke them down into, at this level, or fairly high level screening or risk screening, we looked at sort of the subgrade or below grade basement elements, electrical infrastructure, communication infrastructure, HVAC systems, building envelope, roofs, the structure itself, landscape areas, and the stormwater infrastructure. And this was, sort of typical to all the building types. And although you could have a number of subcategories, this was a good snapshot in terms of all those areas. And the basis of building this out was talking to their operations staff, because they had a lot of the electrical equipment, a lot of low-grade chambers that had a lot of issues in terms of water getting into infrastructure. So some very specific items. So once we've defined that infrastructure, this is where we start to bring in the climate change element into the study. So really looking at what types of climate events, climate hazards might affect all of these infrastructures, from buildings to a variety of things. So we looked at a variety of summer and winter and temperature, overall temperature events. We looked at rainfalls in terms of extreme events and average events in terms of things, the extreme events in terms of high intensity, high frequency rainfall events are going to be those things that will affect the stormwater systems, maybe affect slope stability in terms of those slopes, affect how and maybe these electrical ductworks and things get damaged as well. But we also would look at, average annual precipitation stuff related to some of the vegetation, the tree canopy, and a variety of things as well. Dry spells, dry equals the potential for fire and fire risks. Wind events, in terms of Vancouver, wind is a huge issue. It knocks a lot of the trees over in terms of on other pieces of critical infrastructure. Wildfires, obviously, both on the campus and off, related to smoke, and just snowfall and a variety of things. And in most of these parameters, we're seeing that these events are probably, we'll see a higher intensity and degree of these into the future. And conversely, a few things like snowfall may be less in the future. So with warming, they'll see less snowfall and more rainfall events. In terms of the PIBC process, we turn this into a very boring engineering-based table. We use these tables to assess likelihoods, but really what we look at is turning now all that climate information into some idea of a likelihood score so that we can do the risk assessment. And when we do that risk assessment, we do a slice of that risk at the present time, and at some future time frame. In a lot of cases, when we look at global climate models, we look at data sets around the 2050, 2080. We could look into the 2100s and beyond as in terms of future climate. And we tend to also look at a more worst case scenario in terms of more climate change, not less climate change when we're assessing. Hopefully we're wrong, but it's probably a good starting point in terms of assessing. So using like an RCP 8.5. Once we put all that information together, we'll once again meet with both the technical people that we bring in terms of the team, as well as the operation and management. We go through a risk assessment process, and that's really through a series of workshops. We have really a discussion on consequence. If it rained very hard on these buildings, on their roofing systems and building envelope and membranes, what would the consequence of that be? Would it be a high consequence or low consequence in some score? And for each of those interactions and elements, we go through that process. So it's quite time consuming, maybe a little bit dry at times, but it's also a very valuable conversation, understanding how infrastructure reacts. At the end of that, we come up with a risk assessment profile of all of the interactions in terms of the assessment. And we start to look at that in terms of what do we do with that. So we tend to break risk up into low risk areas where we don't foresee much will happen. There's still an opportunity for things to happen, but not likely. We'll put our energies more into things that might be medium or high risk. The high risk stuff we should probably look at and do right away. Medium risks we might have to look at a little bit more, pay attention to as we move forward and redo these assessments into the future. So it's really trying to understand the risks in terms of infrastructure in a variety of ways. And there also as buildings are retrofitted, upgraded, there's the opportunity for adaptive capacity in terms of things moving forward. So once we have all of this risk summary, we start to look at sort of impacts related to infrastructure, and then we can start to determine actions to reduce those sort of and moving that forward. So in terms of Capilano University, a lot of the actions related to how they would move forward with this master plan moving to the forward. So really what they found out was that they really need to look at the stormwater management in terms of the overall campus and site, because water was affecting electrical conduits, it was affecting all the below grade structures, and it was really impacting their buildings in terms of things. So they needed to understand that better and then start to have a program of making that better. They needed to address natural gas and wildfire risks. There was a natural gas pipeline that went right by there, and they had a lot of issues related to if wildfire had taken place near the campus, that there was a potential for some really catastrophic events. Overall wildfire management, be an urbanized campus, how they manage the flow of students and staff and teachers throughout the areas, very, very important in terms of understanding human behavior to reduce the opportunity of wildfire and tackle things in terms of that. As well as Vancouver's had a lot of, in the last couple of summers, the warmer, drier weather sounds great for Vancouver, but also it also shows that there's a lot more fire, and fires coming from different regions can create a lot of smoke. And we saw that as well in Manitoba in the summer, smoke from other areas, but heavily impacts the HVAC. It heavily impacts a number of other things related to buildings, as well as this campus being, a little bit more in the Vancouver region with outdoor classrooms and a variety of things. So really a number of actions related to that as well. So that's the Capilano University in terms of some assessment. So really in terms of how to do the risk assessment and when, you can do it in a master planning exercise. You can kind of look at some high level risks and inform some of your next steps in terms of planning. Another example of an assessment was on some buildings at the University of Saskatchewan, the engineering building in terms of this, and also a future engineering building that they were looking at. So they did assess this sort of historic building in terms of all of the systems, building envelope, mechanical, HVAC, and a variety of things. But they also were planning an addition or a new building and wanted to use or inform some of the risk assessment in terms of how to plan that into the design works. So once again, looked at a number of climate elements across a number of categories in terms of the buildings and building envelope and structural, mechanical, electrical, and communication and civil works. Once again, looked at the future timeframe, sort of the near future in terms of the 2050 data sets, 2080 horizon being a little bit farther out, and once again, a more worst case climate scenario. We used to call it worst case, but I think that there's probably, it's just a worst case scenario. Went through the risk assessment process and started to address these risks. Here's just some general ideas of some medium risks that were identified in a variety of things and in terms of things. So it can be very, very data consuming. It can have a lot of impacts, but it really can inform a lot in terms of the planning moving forward. And really the basis of the final steps in terms of this assessment was just a standalone assessment in terms of reporting, moving forward with a number of actions and opportunities for the university to take in terms of addressing some of these high priority items, some very easy, not easy, but some very near-term solutions in terms of addressing some things that were very deficient in terms of current related to climate and will only get worse with the future climate. So that's one aspect of just sort of an audit in terms of the risk assessment on a facility itself. I'm not going to get into too many other examples because I only wanted to speak for around this amount of time, but there are many examples in terms of other assessments on building and building type infrastructure. If you go to pibc.ca, there's a number of reports and case studies related to that. And once again, we see a lot more risk assessments embedded into a lot of the processes like climate lens and climate resilience assessments, where we're starting to see these processes. There are very intensive and comprehensive assessments that are very quantitative, that you can bring a lot of data to, but there's a lot of also, there's some high level screening initial steps that are very qualitative or that are really good initial steps that are good at different planning stages. So that's kind of hopefully some of the ideas without getting too deep into the weeds in terms of climate risk assessments in terms of things. So thank you for your attention. Hopefully I didn't lose my internet connection along the way and was talking to myself. So
sounded great.
That can happen. So by the way.
Yeah, no, it sounded great. All right, so we're just headed over into the question zone. Does anybody have a question? And Jeff, do you just want to stop sharing your screen so we can see? There we are. Nice, nice, nice. Kurt, I see you unmuted. There, and hand is up. Take it away.
Yeah. Hi, Jeff. This is like in many ways, like the risk assessment process. It's kind of the view is towards preparing for the future, right? But just this last weekend, I became aware of the Loblaws distribution warehouse here in Winnipeg. It's responsible for supply for all of Loblaws in Winnipeg. The roof collapsed because of the snow load, right? So my question is more a matter of, maybe more building owners should take on this process for the present and the present risks, rather than thinking, well, this is something nice that I might be able to do for some time in the future. So what are your comments on that?
Yeah, absolutely. I think, I've been doing these kind of risk assessments for probably over 15 years with communities on a variety of types of infrastructure. And I would say that because climate change brings us to the table of some future challenge, it really, most of these owners have never thought of risk in terms of even today. So I think it's a great process. Yeah, you look in the future, but really you kind of look to today. And I think they're very surprised at, first of all, I can tell you, if it's going to fail today, it's not going to be any good or better for you to the future. So that's, the discussion on infrastructure deficit, all of these needs of infrastructure. So climate change is only making that worse. So we're already starting from behind in terms of things. So I think the opportunities of climate change, not that we wish we had other ways for opportunities, but the opportunities that people start to pay attention to climate, today's climate, buildings, energy, and also not forget that as we move to sustainable buildings, net zero stuff, that we still need to be resilient, that we still have to look at that future climate, that we don't want to be so precise that we fail into the future and that we've missed the objective as well. So we have to find that balance and that opportunity, because you can't separate mitigation and adaptation. But I think to your first point, just awareness of the risks is really the primary thing. And yeah, it's probably the first time that I would say that managers have heard their operators tell them how bad it is. They don't always get there.
So this is a follow-up question, a follow-on to that. Okay, so if a building owner or manager is aware, how do they go about doing this? Do they have to engage associated engineering to do this? Because I know, Jeff, you're one of the few that have really got a tremendous amount of knowledge and experience in this. There are a few practitioners, but not a huge number. Is there a way that they can do like maybe a bare bones assessment on their own, or what's the process? How do they go about doing it?
I think they might. Most organizations might need a little bit of help at the beginning stage with the process, but there's a lot of things like we've just working with Kurt and I. We worked with the Manitoba Climate Resiliency Training in terms of trying to build more awareness in terms of climate risk assessment principles. So I think over time, just having more people pay attention to it, have more capacity in the industry. It's not meant to have specialists come in and help you on each thing. We're probably too expensive in many cases. But really, the opportunity there is to probably start small and to build the capacity in your organizations. You can do a tabletop risk assessment as part of your capital plan and look at climate. You can do it very simply at a high level screening. These guides, like the PIVC high level screening guide that was just published through Climate Risk Institute, is one. It'll walk you through that process. So I think it's very straightforward. I've been training engineers, technologists, planners, operations management people for the last 15 years across Canada, internationally on these processes. A couple of days of training and they're ready to go. It's not a complicated thing. It's kind of the Nike, but just do it. Get out there and just do it. How do you start? I think you start by investigating and trying to do a risk assessment. You can start small. You can, without a lot of information, you can have a very valid results. When I started these assessments or doing these for communities 15 years ago, we would have to contract out climate services to practitioners, specialists, climate scientists. We would pay like $50,000 for data related to a particular project. Now you go to Climate Atlas at the University of Winnipeg through the Prairie Climate Center, climatedata.ca, PKIC in the BC coast, and you have all that information available for you for free in 10 minutes. So the information is there, you know, a little asterisk that you should have somebody with climate awareness and enough competency to distill that, but it's there. I mean, so we have most of the tools in our toolbox. We just have to start to build something.
All right, we have a question in the chat. Are there regulations and requirements for buildings owners or operators to do risk assessments, or should there be regulation?
Yeah, I don't think that, well, I would say that some municipalities are starting. I know Infrastructure Ontario is starting with all of their new projects to do risk assessments. City of Calgary is embedding that into some of their processes, these climate risk assessments. The federal government is mandating it with their funding related to climate lens in terms of ICIP and other disaster assistance funding. And I would say hopefully more and more municipalities are starting to think about this in terms of their regs. I know BC Highways has embedded this into their process as well. So I think it's the starting point. You know, I know that there was some communities in the BC interior that are trying to get that into building codes, into their bylaws and things as well. So I think that we're close, and that would be a great place for it, because then it's a level of service. You know, the municipality says thou shalt consider future climate change, and risk assessments are a good place to do that. You know, I think it's irresponsible to, you know, build something that's going to last 80 years and think that it won't have to perform at the end of life. So hopefully that answers the question.